We will continue our discussion on Laplace transforms. First question is find Laplace L of cos Wt and L of sin Wt. First one is L of cos Wt. L of cos Wt or cos omega t. L of cos Wt is equal to, what is the Laplace transform? It is integral 0 to infinity e raised to minus st. Here f of t is cos Wt, therefore it is e raised to minus st cos Wt dt. Then we can find out the integral using the standard result in integration, that is integral e raised to ax into cos bx plus c dx is equal to e raised to ax divided by a square plus b square into a cos bx plus c plus b sin bx plus c. Here instead of the variable x, here the variable is t, and here the coefficient of x is a, here the coefficient of t is s. So integral 0 to infinity e raised to minus st cos wt dt is equal to e raised to ax, that is e raised to minus st divided by, here the coefficient of t is minus s, therefore a square plus, and b is the coefficient of t in cos, so it is w, therefore e raised to ax, that is e raised to minus st divided by a square is minus s square plus b square is w square into a cos, that is minus s cos bx plus c is cos wt plus b is w sin wt, where limits are 0 to infinity. Then 1 by s square plus w square is independent of the variable t, so taken it's outside. Then first term is minus s into e raised to minus st cos wt plus w into e raised to minus st sin wt. Applying the upper limit, minus s is independent of t, therefore it is constant, taken outside, minus s into, applying the upper limit infinity, it is e raised to minus infinity is 0, therefore applying the upper limit, first upper limit is 0, then applying the lower limit 0 to this term becomes e raised to 0 is 1, cos 0 is also 1, therefore it is 0 minus 1, plus w is constant, taken outside, w into, applying the upper limits, e raised to minus infinity is 0, therefore it becomes 0, and applying the lower limit, that is e raised to 0 is 1, but sin 0 is 0, therefore 1 into 0 is 0. Then that is 1 by s square plus w square into minus s into minus 1, that is plus s. W into 0 is 0, therefore it becomes 1 by s square plus w square into s, that is s by s square plus w square. Therefore the Laplace transform of cos wt is equal to s divided by s square plus w square. You can also use the notation instead of w omega. Then similarly we can find out the Laplace transform of sin wt. Using this integration result, integral e raised to ax sin bx plus c dx is equal to e raised to ax divided by a square plus b square into a sin bx plus c minus b cos bx plus c. Using this result, we can easily find out the Laplace transform of L of sin wt is w divided by s square plus w square. Next one is Laplace transform of t square. That is L of t square is equal to integral 0 to infinity e raised to minus st f of t is t square, that is t square into dt. That is equal to integral 0 to infinity t square into e raised to minus st dt. Since we have to apply the uv rule, the first function should be a polynomial, so that's why we rearrange it. Therefore it becomes integral 0 to infinity t square into e raised to minus st dt. Applying the uv rule, first function is t square, first function into integral of the second is e raised to minus st divided by the derivative of minus st with respect to t is minus s, minus derivative of the first function is 2 into t, integral of the second function is e raised to minus st divided by, already there is minus s into again derivative of minus st is minus s, that is s square, plus derivative of 2 into t is 2 integral of e raised to minus st divided by s square is e raised to minus st divided by minus s plus s square into minus s, that is minus s cube. Applying the limit 0 to infinity. Then applying the limit to the first terms, that is t square into e raised to minus st divided by minus s. Applying the upper limit minus infinity, plus infinity, it is e raised to minus infinity is 0. And applying the lower limit, that is applying the limit to the variable t, that is applying the limit lower limit 0, it becomes 0. Therefore upper limit is 0 and lower limit is also 0 for the first term. Therefore the first term becomes 0. Then second term, similarly we can find out the second, applying the upper limit and lower limit, the second term also 0. Minus 0 plus 2 by minus s cube, that is constant, therefore taken outside, minus 2 by s cube into applying the upper limit e raised to minus infinity minus e raised to 0, that is equal to minus 2 by s cube into e raised to minus infinity is 0, e raised to 0 is 1, therefore we get it is 2 by s cube. Therefore the Laplace transform of t square is 2 by s cube. Similarly, we can find out L of t, that is Laplace transform of t, Laplace transform of t raised to, in general, Laplace transform of t raised to a. Next problem is L of sine square wt. L of, first we have to use the trigonometric relation of sine square theta. Sine square theta is 1 minus cos 2 theta divided by 2. Instead of theta, here it is wt. Therefore sine square wt is same as 1 minus cos 2 wt divided by 2. Next we apply the linearity property. The first term is 1 by 2. Therefore 1 by 2 into L of 1 minus 1 by 2 into L of cos 2 wt. This is applying the linearity property. L of a f of t plus b into g of t is equal to a into L of f of t plus b into L of g of t. Then we know that L of 1 is 1 by s and L of cos 2 wt is s divided, L of cos wt is equal to s by s square plus w square. Instead of wt, here it is 2wt. Therefore it becomes s divided by s square plus, instead of w it is 2w, therefore it's square, that is 4w square. Therefore Laplace transform of L of sine square wt is equal to 1 by 2 into 1 by s minus 1 by 2 into s divided by s square plus 4w square. Similarly, we can find out what is Laplace transform of L of sine t cos 2t. That is, using the result trigonometric relation 2 sin a cos b is sin a plus b plus sin a minus b. Here it is, instead of a it is t, instead of b it is 2 into t. And then we can apply the standard trigonometric relation and we can find out this L of sin t into cos 2 into t is equal to L of a plus b, 2 sin a plus b, that is L of t plus 2 into t, that is L of sin 3t minus sin t divided by 2. Applying the linearity property, it becomes 1 by 2 into L of sin 3t minus 1 by 2 into L of sin t. We know that L of sin wt is equal to, what is L of sin wt? L of sin wt is equal to w divided by s square plus w square. Here instead of w it is 3, therefore it is 3 divided by s square plus w square, that is s square plus 9 minus 1 by 2 into L of sin t. We know that here instead of w it is 1, therefore it becomes w divided by s square plus w square, it is 1 by s square plus 1. Similarly, we can find out the problems on Laplace transforms. So these are the basic transforms, that is L of 1 is equal to 1 by s, L of t square, t raised to n, e raised to at, cos wt, sin wt, cos hat and sin hat. You have to by heart these basic transforms, since these basic transforms are used to solve the remaining problems.